Good morning, ladies and gentlemen. Today we are going to be talking about multiplying monomials. Our objective for this lesson is to be able to simplify expressions involving powers of monomials. A monomial is a number or variable or a product of a number and one or more variables. Monomials do not have addition or subtraction symbols. So are the following things monomials? So basically what we are looking for is to see if we have an addition or subtraction symbol separating two things. So this one, we have a term and we have a plus sign right there. So the plus or minus sign has to go in the front. So we have two terms, so this thing would not be a monomial. Next up, we don't have any plus or minus signs, so this is one term, so we would say that yes, this is a monomial. Our next one, we still don't have any plus or minus signs, so once again we would say that yes, this is a monomial. Moving on. Simplifying expressions. To simplify an expression involving monomials, we write an equation, an equivalent expression in which the following things are true. Each base can only appear exactly once. There are no powers of powers. All fractions must be in simplest form. Let's talk about what this means. So we have exponents here. So the red arrow is called the base, that's the bigger number. And the smaller number is called your exponent or your power. We have some properties to talk about, which we actually talked about the other day when we were working on multiplying polynomials together. And we will now describe the shortcuts here so we can go fast. So first thing is we have a product of powers. Basically that tells us if we have two terms with the same base and they are multiplying each other, we can simply add their exponents together. If we have a power of a power, that basically means we have a base raised to a power, and then outside of that we have it raised to another power. When we have that happening, we can simply multiply their exponents together. Our final example is if we have a power of a product, that means we have two bases inside some parentheses. Basically, you raise each of those individually to the base that is on the outside of the parentheses. I'm going to move on with this video, but I would highly recommend you pause and write that down. So let's go ahead and look at a couple examples here. So what I like to do is I like to break these down into individual parts. So here I have 5 times x to the 7th times x to the 6th. So I've broken it down into each individual part. So I have the 5. I have nothing that I can multiply the 5 with, so I just simply am left with 5. X to the 7th times x to the 6th, those are two same base things, so I can add together their exponents. So 7 plus 6 is 13, so it's going to be 5x to the 13th. Our next one, let's go ahead and break that down. So I have negative 4 times r times s squared times t cubed times negative 6 times r to the 5th times s squared times t to the third. So I have negative 4 times negative 6 is my first thing that I have. So just for help, I'm going to actually circle these in different colors so you can see what I'm actually doing. So negative 4 times negative 6 is going to be 24. Next up, I have an r. This r really is to the first power, and I have an r to the fifth. So r to the first times r to the fifth is going to be r to the sixth because we add the exponents together. I have s squared and s squared. So those are multiplying, and so I can add their exponents together. So I have s to the fourth power. And finally, I have t to the third and t to the third. Those are same base as multiplying, so 3 plus 3 gives me t to the sixth power. So my final answer is 24 r to the sixth, s to the fourth, t to the sixth power. Next up, I have a power to a power, so that's y to the third to the seventh. So I like to make sure that I take my outside thing and multiply it by each thing. So 3 times 7 is going to be 21. So I have y to the 21st power. On my next one, I actually have that thing. I have 2 power to a powers happening. So 2 times 3 is going to give me 6. So I can rewrite this as 3 squared to the sixth power. Now I have another power to a power. So I multiply the 6 times the 2 there. So I'm left with 3 to the 12th. So let's go ahead and move on. So let's go ahead and simplify these expressions. A little bit tougher, but nothing too crazy. So I have a exponent on the outside there, so I have to raise each individual thing by that exponent. So I have 3 to the second times y to the fifth to the second is going to be y to the 10th. And then I have z to the first power, so 1 times 2 is going to be z to the second power. Now, I can do a little bit of simplification here. You could leave it as it is. However, 3 squared is pretty easy to do. That's just 3 times 3. So 3 times 3 is 9. I still have y to the 10th, and I still have z squared. Let's go ahead and look at our next problem. I am raising everything to the third power. So I have negative 2 to the third power, f squared to the third power, so 2 times 3 is going to be f to the sixth, and g to the first power to the third power is going to be 1 times 3, so it's going to be g to the third. Now, once again, could leave it like this, it would be okay, but it's pretty easy to do. Negative 2 cubed, that's negative 2 times negative 2 times negative 2. And negative 2 times negative 2 times negative 2 is actually going to be negative 8. So I get negative 8 f to the sixth g to the third. And that's my final answer there. Here's our last set of problems for this one. So it says express the area of each figure as a monomial. So our first figure is a rectangle. So to find the area of a rectangle, remember area is your base times your height to find the area of a rectangle. That's right there. So to do that, basically we have to multiply this times this, which is pretty easy to do overall. I will simply write it out for you guys. So I'm going to write it out spread out. So I have 2 times x times y squared times 4 times x times y times z squared. So let's go ahead and multiply each individual thing together and we'll be done with the problem. So I have 2 times 4. 2 times 4 is going to be 8. I have x to the first times x to the first, so I need to add those exponents together. So it's going to be x squared. I have y squared times y to the first, so that's going to be 2 plus 1 is 3. And then I have a z squared by itself, so I just have z squared. So that's actually going to be my final answer right there. 8x squared, y to the third, z squared. Now the area of a triangle is slightly different. It is actually 1/2 your base times your height. That's for a triangle. So let's go ahead and do that one out. So I have 1/2 times, my base in this case is 8 times k to the third. My height is 5 times k. So once again, let's go ahead and multiply all our like things together. So I have a half times 8 times 5. Those are our numbers. 1/2 times 8 is 4. 4 times 5 is 20. If you didn't know that, you can simply do that on your calculator. And then I have a k to the third and a k. So I have 3 k's and 1 k, so it's going to be k to the fourth. So my area of that triangle is 20k to the fourth. That brings us to our end for today. Have a great rest of your day.